Good afternoon, everybody.
Hello, Dr.
Hello.
Hey, how you doing?
Hello.
Yeah, Antarctica is the only continent that doesn't have COVID-19, so I decamped there for the duration. So
Absolutely worth it.
courtesy of a Zoom background.
That's wonderful. Thank you so much for meeting with us today. We might have a few more people coming in and out as time goes on, but we really do appreciate your time today. So for those of us who we're all here, I'm sure we all know a little bit about Dr. Shubin, paleontologist, anatomist, scientific communicator, professor, and has written 3 books, one of which just recently came out.
And can I just interrupt for one sec? If everybody who's not speaking, just hit mute because there's a ton of feedback going on. Can't really hear.
All right, are you able to hear me okay now?
Yeah, there's a lot of other feedback. Sorry. Yeah, go ahead. I'm sorry to cut you off.
Oh yeah, no, absolutely. So of course you've written your 3 books, Universe Within, Your Inner Fish, and then the one that just came out, Some Assembly Required, which I know a few of us already own as well. So as I said, thank you so much for meeting with us today.
My pleasure, of course. Awesome.
The majority of us came to know one another because Molly Selba and John Mead actually, along with Dr. Amanda Glaze, hosted a human evolution training this past summer at the University of Florida, which is how we all came in contact with one another. We range in subject areas, mostly middle school and high school, but we do have some upper elementary as well.
Oh, awesome.
And so we, again, are just extremely passionate about evolution education, which is why I'm so happy that you're here with us today.
Well, that's why you guys are on the front lines. That's why I'm happy to be here myself. My goodness.
Thank you.
Pleasure's mine.
How did you want to go about it? Is there anything you wanted to share with us first? Do you want to primarily do questions? It's up to you.
Oops. There's Tiktaalik. Yay. This is the type specimen at Tiktaalik. It's a cast of the skull, really high fidelity one. Not the same color. The original is red. But anyway, I've just brought it in to give you a sense of things. I'm more than happy to answer your questions. To talk about what we're doing research-wise now. I mean, I can take this in any direction you want to go. So.
Well, let's go ahead and start with you telling us about the research that you're doing now, and after that, we can head into some questions, if that's all right.
Okay, so you know, we found Tiktaalik in 2004, in July 2004. It was after like a 6-year hunt, right? So, and then it took 2 years to publish it. So 2006 is when the world found out about it, but we had it for like 2 amazing years where only Ted and I and Farish and our crew knew about it, and we were like, oh my gosh, wait till the world sees this. That was an amazing time as we published that paper. But since that time, we've returned to the Arctic, the same site in the Arctic, in general region, about 5 more times. And we now have about 20 specimens of Tiktaalik. It's not rare. That's what most people think. It's not one specimen. It's a lot of specimens. And it's really high quality specimens. Like this one here is not even the best preserved one. We have this all the way to the base of the tail. We have some that are bigger that are actually better preserved. So we have lots of specimens. We can look at variation. You can do a lot of good evolution when you have that sort of data set. But the hunt just continues. So what you see behind me is Antarctica, which is where we've been working, helicopter. And see those mountains in the distance? You know, you can see in the distance there. Those are Devonian. So we've extended the search to the South Polar region with an idea. Those rocks are slightly older than the ones that preserve Tiktaalik. So Tiktaalik is about 375 million years old. These are about 380, 385. And the reason why we want to do that is we want to see a little bit lower in the tree, deeper in the tree, how those characters distribute. And this was a perfect place to do it because those mountains that are in the distance are sort of middle to late Devonian age rock poking through the ice. So you see that's Deception Glacier right there, that glacier. That's about 6 miles across the glacier. So you snowmobile over there. But to get to those, the whole rim of mountains out there. In fact, behind where the helicopter is pointing, behind me, we're a bunch of mountains too that are Devonian. And they represent ancient rivers and streams, ancient delta systems, same environment that we have up in the Canadian Arctic where we found Tiktaalik, only older in time. And so we found some early sharks. We've had 2 expeditions there, early sharks. We found a Tiktaalik-like creature a little bit lower in the tree. We found early bony fish, things called placoderms, lots of those amazing ones, including little embryonic ones with soft tissue preserved. Really, I haven't published it yet. In fact, one of the challenges is with my lab being shut in the current situation, we're not really able to do much, although except for one project, which I'll share for you in a sec. So we've continued a lot of field expeditions, different time periods in the Devonian, different areas and so forth. More Tiktaalik-like creatures have come out in other places of the world, discovered by other teams in the last 10 years. There's a creature called Panderichthys, which has been known for a while, but more material has been described. There's another creature called Elpistostege, which has been known for a while, that was recently redescribed, and there's a new specimen discovered. So we have a rich knowledge of this part of the tree of life, which is really remarkable. You know, it's really privileged to have all this great fossil material that bridges the fish to tetrapod transition. And also we're interested in understanding the environments that all this stuff happened in. So that's what these rocks are great for, because we can do good sedimentology and geology and all that good stuff. So that's one of the areas we're doing. The other big area we're doing is my lab's big into molecular biology. Half of it is molecular, most of it's molecular biology now. And we're looking at Hox genes and other genes and developmental control genes and the relationship between fins and limbs and how those genes function. And, you know, and the take-home message there, which I tried to capture actually in the new book, Some Assembly Required, is that, you know, many of the genes that are necessary for building and patterning our hands and feet, our wrists and digits, are present in fish. And they're patterning the fins of fish. And what are they doing? They're patterning the terminal end, the distal end of the appendage of fish. So, and so we can see how ancient genes have been repurposed to make new structures. And then my lab has been very active in that, looking using zebrafish and other extant fish to understand like the principles of fin development and how they compare to the principles and patterns of limb development. It's been very productive. We've had a series of papers in the last few years on that as well. And finally, just between us friends, we have a really interesting discovery. I'll tell the story. So this is July 2004, the year we discovered Tiktaalik, right? 3 days before we actually discovered this specimen, right? We didn't have much to show for ourselves. And we had really bad weather. We couldn't get to the quarry, which ultimately held the type specimen of Tiktaalik. So I was like, hey, everybody do your own thing today, prospect locally around camp. So I went up a hill right by camp, some Devonian rock, and I sat down. I wasn't finding anything, had lunch. Looked down and there was like a there's a red rock, the rocks there are red, a red rock with some white patches on it. And 95% of those white patches that we find in the Canadian Arctic are either lichen or bird poop, not fossil, okay? And so I'm like, leave it, it's just a lichen or bird poop or whatever. But I got bored or whatever, and I picked up the rock, and it was a series of scales that I only noticed when I put my eye right to the rock. And it was a particular kind of scale. It was a kind of texture that looked like it would be a bridge animal. I knew scales a lot really well. And this thing looked like it could be a Tiktaalik-like creature. We didn't know Tiktaalik at the time, but it was in the ballpark, right, in terms of the scales. So I collected every rock around there. There was not a whole lot of bones showing. So I collected all the rock around there and brought it home. And there it sat till about 5 months ago, where we had all this time for our CT scanner downstairs in the lab, high energy CT scanner, you can really zap it, you know. So we zapped the block, and guess what's in there? Another kind of Tiktaalik that's really small. There's a fin, there's a head, front of the head. It's not complete, you know, it's bits and pieces, but it's enough to really, you know, get to see it. I'm really hopeful about the fin. We found the fin in the block in January. Seems like 10 years ago, right? I mean, but in January, about a decade ago, an emotional time. But we found it, and yeah, we were really excited. So we have the scans, low resolution scans. We got to rescan at a high resolution. We were just doing like searching scans, which are low res. But you know, when the world opens up again, guess what's going to happen? We're going to go right in it with high powered scans and get this thing described. So we're very excited about that, because it's about half the size of this specimen. Clearly sort of different, same but different, flat head, similar sort of texture to the bone. But there's different geometry of the jaw, at least as we can see. So it's clearly a different genus. I mean, it probably won't be called Tiktaalik, it'll be called something else. But so that's really exciting. And of course, you know, I have lab meetings twice a week now through Zoom. And that's kind of what we talk about. Like, we're trying to glean every piece of data we can out of this low res scan. You know, we had a meeting on Monday and we're just going through it, trying to like just glean it, you know. We're just really excited. So trying to make as much hay of it now with low res stuff, but it does seem it does seem to hold an enormous amount of promise. So, and then this stuff too, the Antarctic material as well. We were there last year from end of November through end of January. It's kind of a rough time to go. You miss Christmas and New Year's and Hanukkah and birthday parties, and you miss all the stuff, right? And it's really challenging for everybody, including families. But we have a rich haul from there, but we can't work on it now. We haven't scanned that material, so that's sitting in the lab. Most of that's in Philadelphia with my colleague Ted Deschler right now. So we're gonna have to figure out a way to get that done. But long way. The search never ends. We just keep on going. I have all kinds of field plans. I'd like to get out again when things, calm down, and they will, and we'll be out eventually. So that's just kind of where we're at now. So I had some assembly required. The book was released at the worst possible day for a book release. It was March 17th. I had a 16-city book tour, going everywhere, giving talks. We had press tour, we had talks, we had all these interviews. That was all canceled. And so what I decided to do is, knowing that it was canceled, and I have all that book tour time on my hands, I just basically converted it to a meeting with classes and teachers and things like that. So I put the announcement out on Twitter and Facebook and social media, and try to get the word out. And it's funny, I didn't have a huge response initially. I'm like, okay, whatever, don't take me up on it then. But then when I got the biggest response is when I posted pictures of me being in a class with other teachers. You get the FOMO thing going, right? If you're missing out. And so that worked wonders. Now I have about 60 of these meetings going through mid-May. I'm excited to do it. It's really fun, and I'm enjoying it. And what's lovely about it for me is, it's not about selling books. It's just really about meeting teachers and their students. It's about answering questions, and the students often bring a lot of energy, and teachers bring a lot of energy to it, which elevates my day. So there'll be some days where I have 3 or 4 of these meetings. They go about half hour to 45 minutes. And I'm just in a happy space, during the quarantine. It puts my mood in theirs. It's a really good thing. And I may continue. It depends how long this quarantine goes on for. And different states are probably going to handle it differently, but I'll probably continue it a bit. I'm just scheduling. I'm not saying no to anybody at this stage, because I have plenty of time. If I do 2 or 3 a day, it's not onerous at all. So that's where we're at.
Well, that is really fabulous. And thank you so much for sharing, again, the story of Tiktaalik, kind of back from early 2004, and then also sharing with us about the new little one.
Is that cool? Yeah, it's really fascinating.
Yes, that's amazing.
It's really detailed morphology. It's a little hard right now for me to know what it is, because it's like little subtle features that differ. It's like really primary systematic description.
Well, I know that I have a ton of questions, but I know I've talked a lot as well. So if we just want to do actual raise of hand, and then Dr. Shuman, if you want to call on people, or I can, it's up to you.
You just go ahead. You run the show.
That sounds good. All right, questions. Okay, I'm going to start at the top of my screen, which is going to be Leslie. Go ahead.
Hi, I am so happy to be face-to-face with you. I've actually spoken to you through chat on Facebook years ago. I incorporated Your Inner Fish in some instruction that I had in class that was just amazingly received.
Oh, wow. I love hearing it.
Yeah, so I really appreciate your openness to just be available. And really, I don't have a question right now. I'm sure I will as we continue to talk, but I just wanted to say that the passion and excitement that you have today, just sharing your story about what you're discovering and what you're excited about and where you're going, is like contagious. And if we could capture that, you're sharing that with all of these educators and all of these students, then you're really just piquing interest in the scientific career field. And I think that's just amazing.
Well, thank you. One of the things is, like, when I was originally thinking about writing Inner Fish, I wanted to convey, that's actually what I wanted to convey. I mean, there's certainly the facts I wanted to get across, but also the stories of discovery. But I wanted to communicate like the joy of doing it. And there's sometimes the pain, you know, I mean, Tiktaalik wasn't, you know, finding Tiktaalik wasn't always easy, right? It was a struggle, but, you know, but we kept a good attitude about it. And you know, I do like doing science. And if we can get that across to students, that's a success for all of us as educators. Thank you.
Thank you. I don't know, Caitlin might have gone to be a mom. So Brianna, I think
Anybody can pop in there, yeah.
All right, I will jump in. It's so great to meet you, and thanks for agreeing to meet with us over Zoom.
My pleasure.
I'm a teacher who has incorporated Your Inner Fish into my classes in the past, and I just finished reading, because it's my spring break right now, the newest book, Some Assembly Required.
Oh, thanks.
And I teach AP biology, and I'm really inspired by the book to try to figure out a way to incorporate it as kind of the story for my entire class next year, and kind of going chapter by chapter and seeing where it aligns with the College Board units. And so my question for you is, do you know of anybody else that's kind of using it as a pathway through their course, or what resources they're using? Or do you know of any resources that I could use with AP biology students to get them really into the material?
Yeah, so when I wrote the book, I really did at the end of it, there's a really detailed set of notes of extra resources that you can do. So I did a sort of a parallel book in the notes. They're fairly long for a reason, because I thought, you know, if educators are using it, or maybe curious students or general public, they're going to want to follow up on a treatment that is, you know, the treatment works on two levels. I wanted it to work like a Pixar film, right? So, you know, kids and their families can get into it. And that's why I had those fairly detailed notes at the end. I would take a peek at those first, because there's a lot of good resources, other books that folks have written that I like to recommend. There are websites and so forth that I mentioned back there. Quite a few, actually. We're really, you know, can you imagine if we had to do remote learning like 15, 20 years ago? It'd be a totally different experience. We have so many resources now. And again, they're in the back of the book to check out. You know, the book's only been out for 2 weeks, so I really haven't had any interaction with teachers around it yet. And usually it takes one intrepid teacher to do it, and they sort of work out the problems, you know, they have some good things and lots of good things, you know, so they work through it a bit. But one thing that I tried to do in that book is to tell the story of people doing science who had to really struggle doing the science. And I thought that's very compelling for a lot of people. You know, no one likes somebody who's purely successful all the time. You know, I mean, we hate them, right? You know, I like to tell the story of people who had to struggle for the discoveries that they made, either because of their life circumstances or because of how the science played out. So you know, again, those were sort of narrative devices that I tried to use in the book as much as possible. And I think for students, the ones that when I've talked to students, particularly, you know, my teaching here at the University of Chicago, let me turn off the background because I'm disappearing a bit. For my students here at the University of Chicago, actually, let me go back to the background. I like the background. I'm sorry, I'm going to give a new background. How's that one? There we go. This is our test camp in Antarctica. For the students, for my students at Chicago, and I've used parts of that book in my own class as I was writing it, they liked the entree to it. If it was a compelling character, it was a great narrative device for me to teach the class in a lecture setting. So that's kind of what I would recommend. So try to find a character in the book or in your own reading around that material, and build interest that way with the narrative of you know, somebody who really had to work at it, who got lucky, or who failed and learned from their failure, or who had a life story like as mind-blowing. Like one of my favorite characters in the book is Julia Barlow Platt. She was born in the 1800s. She went to University of Vermont and she went to Harvard, but she realized she couldn't get a PhD because they weren't giving PhDs to women. So she went to Germany. She did her PhD. She did a great PhD. She came back to the United States and found a very warm person in O.C. Whitman, who was a University of Chicago professor, but he was also at the Marine Biological Laboratory in Woods Hole, and made an amazing discovery, which sort of preceded the discovery of the neural crest, you know, that tissue type that's in development. Nobody believed it because it was so revolutionary, right? And so she couldn't find a job. She got squeezed out of the field. Nobody wanted to hire her. Females in science at that time, is the late 1800s, it was not to happen. And furthermore, she had a very, very controversial discovery that was cutting edge, ahead of the time. She couldn't find a job in science. So what did she do? She moved to Pacific Grove, California, became elected mayor of Pacific Grove, California, and ended up saving Monterey Bay. And then right around that time, she was vindicated by developmental biologists who actually made the discovery of neural crest. And so it's just a great, I love stories like that, because you could teach about neural crest around Julia Barlow Platt, right? That was kind of my conceit. And then there are other characters you can do it around too, but that's kind of how I like to do it.
All right, next question.
I have a question.
Jamie?
Hi. Okay, so this is really more of a comment than a question. Kind of starting or adding on to what Leslie said is I just wanted to say that I really appreciate you as a scientist taking the time to talk to us. I teach advanced high school biology right now. Prior to that, I worked at a scientific institution, and the research department is very separate from the education department. And scientists are really busy. They have a lot going on and don't really take the time. And something that I encounter in my classrooms a lot, especially regarding evolution and climate change as well, seem to be issues of not just getting students excited about science, but also having a sense of paranoia that scientists are sort of this weird cult trying to provide misinformation and take over the world, and there's a sincere fear there, and they kind of see like a white man in a lab coat who's perfectly educated, and that's sort of their mentality. So what you were talking about, the more that we can put scientists in front of students, not only does it provide an interest and they're really impressed that someone actually took the time to talk to them, like they are aware of that, but it also just helps put a face to it, and also those stories that you're talking about of understanding that science can be done by anyone, and it's something that you can access. And scientists don't always look like the stereotypical vision that they have, and they're always,
You mean with gray hair and a beard?
but they're always surprised by that. The more scientists they can see, the more they see that people look different. So I just wanted to say thank you for that. I just appreciate it, and it really means a lot to students.
Oh, thank you. And I think, one of the things to build on your point a bit is to show that scientists can be of different types. That's why I love Julia Barlow Platt. That's why many of the heroes in Some Assembly Required, and in fact in Universe Within, are heroines. A lot of females. And so I like to pull out people who had struggles, and oftentimes there were women working at a time when science was not very female friendly, and or just people who are different, and I think that sometimes appeals to students. And also the stories of discovery themselves, because the stories of discovery, when you really boil them down, they're very human stories of people trying and failing and learning from failure, or getting lucky, or serendipity, or maybe they're really smart and they figured it all out. Just different pathways to success. And the more we can convey that, I think the better. Thanks.
Next question. Brandon.
Good afternoon.
Hey.
I am a high school science teacher, but I also do a lot of public science advocacy. I'm a founding board member of a group called Florida Citizens for Science, and our objective is to promote and defend sound science education within our state. And so I have a special interest in those who always push back against the teaching of evolution in our schools and stuff like that. So my question is, with you being such out there in the public now, based on your discoveries and books and documentaries, are you seeing any of the pushback directly on you from anti-evolution forces? And if so, what's your response to them?
I am going to admit something. I've never had pushback in my entire, except for one day. I'm really serious. I've given hundreds of talks in all over the country, South Carolina, Oklahoma, all the places you'd expect would be a challenge. Never had a trouble. And occasionally one or two radio interviews I do where a caller or call-in is very offended. But, with the way I deflect that, and, who knows how well it works, but the way I deflect it when I do have it, or when I'm in a talk, is I focus like a laser beam on the stories of discovery, because that's what science has. We have the power to make predictions, test predictions. I love the Tiktaalik story in that regard, not just because it's a story that I was involved with, but also that it's prediction and tests. You know what I mean? It's like we knew what we were looking for, and we designed an expedition to find it, and we found it. And here is a fish with an arm inside and lungs and gills and all that stuff. And so, you know, when you focus on that, so if I'm in a crowd where I feel it might be hostile, I focus like a laser beam on the discovery, and then I bring the discovery, you know, like this. And so what can you say? You know, it's like, you know, okay, I'll give you the fish to tetrapod transition, but what about the origin of birds? You know, well, sorry, you already gave me one big one. But you know what I mean? So it's like, that's how I handle it. But I get remarkably little pushback. You'd be amazed. I mean, the only time I really had kind of spooky, scary pushback was when Tiktaalik was originally described in 2006. You know, it came out in 2 papers in Nature. And it got like huge press coverage, like April 6th, 2006. I remember the day. I'll remember it for the rest of my life because, you know, I walked out of my apartment. There's my New York Times. I picked up the New York Times. I had no idea it was going to be the lead story in the New York Times. I was like, oh my gosh. And then the phone started going off the hook and things. That day I had a lot of creepy emails. But that was the only time in my entire career. I'd done Colbert a few times. I've done all, but they're friendly crowds. You know what I mean? It's like, and when I give a talk, even if it's in, you know, Oklahoma somewhere, Tulsa or whatever, you know, it's usually self-selected people who show up are usually kind of more on the other side because they want to give resources to their kids or their students and so forth. So I haven't really had much, but when I have it, I really focus on discovery, the act of discovery, and not just mine. There are others like Hopi Huckster's discovery of, you know, the adaptation in genes in mice. And there's certain David Kingsley's work on sticklebacks. There's work I like to focus on of people who really made a bet, made a prediction, really learned a lot about evolution.
That's awesome. Aubrey.
So to kind of follow up on that question, and I guess I should preface it, I'm kind of crashing this whole party, so I appreciate all of you letting me crash. I know Katie, and she knows I'm a fan, so she let me in. But Dr. Shubin, I was the one who's been kind of emailing you over the last couple of days. I'm the Chicago girl. So my students, and we had a field trip lined up to come to your book signing this week, and that got canceled.
Oh yeah, exactly.
But to follow up with that, I think it's one of the things I really love about your books is how you use non-human evidence to tie to humans. And I think that's something that I really, whenever I get pushback from students, it's with humans. Like, okay, we understand dinosaurs, we understand fish, but not humans. And so I wonder, when you started all of this, because I know you were originally, I think it was Interfish, you were talking about you were teaching anatomy, or human anatomy.
Human anatomy, yeah.
Was that kind of your intention to use the non-human evidence to explain humans, or was that just kind of—
That was the entire piece of it. Yeah, that was the entire conceit. So, I mean, I was teaching human anatomy at the medical school here. I was the course director, by accident, not by design. But before that, what happened, the story behind Interfish is really, I was teaching comparative anatomy for a long time at the University of Pennsylvania, which was my first academic job. And I decided we need a new comparative anatomy textbook. So I started to think about writing a comparative, you know, the classic sort of shark, mud puppy, you know, cat dissection and all that stuff. So I started to think about it and work on it a bit, and I got like really bored. I was like, wow, does the world need another comparative anatomy textbook? I guess not, because there's some good ones that came out. And I'm like, I can't do better than those. What am I going to do? So I was a runner at the time, and I injured my knee, and I had like 2 weeks in bed, or a week and a half in bed, and I'm thinking, I had a notepad, and those were the days before the internet. I had notepad and pen, and I was sort of jotting things down, and I said, you know, what if I wrote a comparative anatomy textbook where it's about fish and worms and flies, but it all relates to the human body? And that's when I thought of the title, You're in a Fish. And as soon as I thought of the title, You're in a Fish, the whole book became clear to me. Not in detail, but, you know, in terms of its overall conceit and the way I would tell the stories and stuff. And that was totally the goal, to tell the human story through fish, reptiles, amphibians, things like that. Worms were possible, you know, and also to fold in multiple lines of evidence, you know, to fold in the fossil record, particularly our discovery of Tiktaalik as an exemplar, the molecular record, sonic hedgehog and Hox genes and things like that, comparative anatomy, you know, which was my first love and all this stuff, which, you know, it comes to the fore when you talk about the ear and the middle ear bones and so forth, and the cranial nerves and things. And yeah, I was teaching human anatomy at the time, so it really sort of forced that connection. I mean, I was teaching human anatomy at the same time we discovered Tiktaalik. And so, yeah, totally forced that. I mean, particularly the conversations I was having with medical students, you know, around it, who were like, well, what are you teaching this course for? Why isn't there a surgeon here? You know, give me a surgeon. I don't want a fish paleontologist. But it, you know, but actually worked out really well. And other conversations had a huge impact on me as well. Like talking, I was also at the Field Museum of Natural History at the time in the administration, and I would talk to trustees, and I would say, hey, you know, the bones inside your ear were originally in jaws of reptiles or like the gills of sharks. They're like, no way. I'm like, yeah. And I realized that like the fundamental amazing stories of my field, nobody knows about. So I figured the best way to tell it is just, you know, to relate it to the human body. And that was the whole conceit of Year in a Fish, you know, and the title all the way down to every single chapter. And so whenever I lost my way writing a chapter, I would always return to that. And that was like, you know, like a guiding light.
That's incredible. Thank you. Other questions? I have one. I have a lot, but I'll ask one. So you clearly have a really exceptionally diverse set of professional experiences. I was rewatching Inner Fish just in the past couple of days, and every time you met with a new scientist, like around the world, I was like, oh my gosh, this guy knows everybody through making this set of documentary series. So you've clearly had tons of experiences. What's left on your bucket list of career experiences?
Oh, what's left? There's everything. I'd like to find the earliest vertebrate. You know, I'd like to go back in time to find the first creature with skulls and backbones. Yeah, I mean, it's about my. It really does come down to the research and the writing. And for me, it's always new adventures. Right now, I'm thinking of a new book. I've got a couple ideas in the back of my head. I'm working on those. You know, you're also building on experiences too, you know, I mean, having this period of quarantine is sort of a good period for me to think about things and put them in perspective, and taking my lab maybe in different directions. One thing we're very interested in now is regeneration as a biological property. And it turns out that if you look at regeneration, you know, we all know about salamanders, right? You cut off the limb of the salamander, what happens? It grows the whole thing back. You know, they get the skeleton, the nerves, the muscles, the arteries, you name it. And it comes back with pretty high fidelity to the original. We can't do that. Not a good thing. It'd be great to have that. But if you look at fish, it turns out most fish can regenerate just like salamanders. So that property of regeneration is not special to salamanders. It's actually primitive if you plot it on the tree of life. It's like the primitive state. Our branch of the tree of life, including reptiles and birds and mammals, lost it. So what did we lose? You know, so that's the kind of question I'm interested in the future. So for me, research is never ending. You know, it's not like you achieve something and you stop. You know, you achieve something and you get to ask new kinds of questions, you know, or it opens up new directions. And so that's one thing I like to convey to students is, you know, it's not like a collection of things. It's ongoing questions. And what differs is you find answers to old things and find new questions, more precise, more interesting, more powerful questions as you learn. So, but it's always about asking questions. So those questions never end.
That's fabulous. Other question, Shani. Shani, go ahead.
Hi, I'm from Mississippi. Just want to tell you again, thank you so much. This is really an honor, and I'm really kind of starstruck right now. So this is really amazing. But I know that, you know, you've gone into paleontology, but what was the defining moment, like maybe in your high school or your undergraduate program?
Right. I lost you there for a second. You cut out. Can you guys hear me? Can you guys hear me? Yes. Okay, good. I lost the last thing you said. Your sound cut out. All right. I'm not hearing you. I'm sorry. Oh, you're muted. It looks like you're muted. Yeah, there you are. You're back.
Okay. What I was, again, I would like to know, because you're really, really very strong in your narrative. I really appreciate your narrative style. It really draws people in. Please don't ever lose that. I think that's what adds to your stardom. But I really am curious about, when did you decide that paleontology was your field? Was it, a high school class? Was it an undergrad? When did you decide this is the path I want to take?
It was undergrad. It was the first, actually the first semester of my freshman year. I knew I wanted to do science. I didn't know, I didn't know what kind of science. I thought maybe astronomy. I thought maybe archaeology, geology. I didn't know. I knew I liked evolution, though. I did a term paper on it when I was in ninth grade. We got to pick out of a hat, like a lottery, and I got evolution. So I'm going to write a paper on evolution. So I read Charles Darwin and all that stuff, and I really enjoyed it. And so I went to undergrad in New York City, and a professor who was also a curator at the American Museum of Natural History was teaching a course on human evolution, Ian Tattersall. And Ian, famous curator, and I was privileged to be in this like 10-person class. It wasn't, I don't know why it was like 10 person, but anyway, so I was really loving the class, and I contacted Ian after the class saying, can I volunteer at the American Museum? And, I volunteered, then I got invited on DIG, and, the next thing I knew, I'm like, here I am going to graduate school. So it's really sort of that path. I mean, I have to relate it, I guess, to the first semester course that I saw. And then there were two things. One is finding the interest, right? So knowing that I liked it, but also as like doing it, knowing I could do it. So when you think about your students, right, you face this all the time, of course, it's like they have to get a certain level of confidence that they can do it themselves, right?
Yeah.
And that's true for all of us, and so that was really important for me, volunteering and things like that. So I got the sense, hey, I can do this sort of stuff. And I wasn't very good, but I saw a path, put it that way.
Thank you.
You bet.
Other questions? Molly. Molly designed our PD that got us all connected, and it was truly incredible, truly amazing. It's all centered around 3D printing, hominid, fossil replicas. She is a truly phenomenal person, and we are so thankful for her.
Awesome.
Thank you, Katie. My question is a little bit self-serving, but since we have you here, I thought I would ask. I'm a fifth-year PhD student who's looking to enter academia shortly. Do you have any advice for someone who's wrapping up their PhD and looking to become a professor?
Oh, advice. Hang in there. It always works out. Everybody I know, it may not work out the first year, it may take a couple of years, but what advice do I have? Well, there are many kinds of careers you can have in academic science. Let's assume you want to be in academic science, right? There are many different paths, and I would encourage you to explore all of them. There are small colleges, there are community colleges, there are big research universities, there are many different ways of being a research teaching scientist. And I would keep a very open mind about it when you look at the different kinds of experiences that you can have. I think when you look at sort of the training of a PhD student, arguably the most important part is not the PhD, it's the postdoc. And so a lot of people really sort of refine themselves in the postdoctoral period, maybe doing one or two of them. Very few people get their first academic job on their PhD and their dissertation. They usually get their academic job wherever it is based on a postdoc. So I would encourage you to try to think about that next step as, is there a good postdoctoral laboratory, a good postdoctoral experience that could round out your own education? So think really carefully about that. And postdocs are really, when you apply to them, it's not about the university in this case. It's not really about the geography. It's really about the lab you're going to be in. So try to choose, if this is something you're thinking of, try to choose a laboratory where you think you would flourish and be productive. And, the best postdocs manage to do that. Right now I have 5 postdocs in my lab, and each one of them sort of at different stages of the postdoc. And it can range in time from, 1 year to 4 years. Now, some people do 5, but I don't recommend that. But, 1 to 4. That's a time to really, that you'll be focused almost purely on your research. You can teach at some institutions if you want. So think about that pretty carefully, what you want to do for your next step and what sort of postdoc could do that. And then also think or explore the different kinds of career opportunities that are open to you in the different kinds of academic institutions, you know, whether it's museums or community colleges or research universities or, you know, big state schools. I mean, there's so many different ways of being a scientist, teaching, researching scientists.
I had my work cut out for me. Thank you for that.
Well, it's an exciting time, though, I got to say. I mean,
Mhm.
for me, the postdoc was a chance for me to explore research. I worked in my postdoc on salamanders. Love salamanders. And I made it into the new book. I mean, salamanders were my thing for 3 years when I was at Berkeley doing my postdoc. And so that's kind of where I rounded out my PhD. So.
Yeah, that's great advice. I'm also a comparative anatomist in a biological anthropology program, but my lab doesn't have any postdocs, so I don't get to interact with them a lot. So this was actually really helpful because I need to remember to investigate that further.
I would, yeah, because that's a great opportunity for you to build your CV, build your research experience, get some publications out. It's a really critical time. So think of it that way.
That's perfect. Thank you.
You bet.
John?
Dr. Shubin, many thanks for sharing with us. And I, as a 30-year veteran middle school biology teacher and one who teaches lots and lots of evolution, especially human evolution, you really spoke to me with the idea of storytelling and the storytelling of discoveries. And that's something I've done for many years. And I'm curious as to your recommendations to us. Who are some of the great scientific storytellers who are not big names yet? Who are the folks that we should be seeking out who are not the Neil Shubins of the world?
Okay, well, let me Sean Carroll's a really good one, but
he's awesome.
He's up there, yeah, exactly. He's on the pedestal. Let's see, who's really good. So in paleontology, Steve Brusati wrote a great book on dinosaurs. Rise and Fall of the Dinosaurs. I mean, Steve's really good, although he's gotten an increasingly big name lately. Doug Emlen is somebody to think about. Doug is, again, he's just amazing. He wrote, what was the name? Nature's Weapons. It was a great book on the arms races behind beetle armor and weapons and so forth. Doug Emlen's another good one. Nick Pyenson is one you might not have heard of. He's wrote a book on whales, spying on whales, just a fabulous book. Obviously Carl Zimmer, you know that. Yeah, I'd say of the paleontologists, I'd say Nick Pyenson. Let's see, Nick, Steve Brusati, Doug Emlen is great. His writing is just fabulous. I'm missing so many people, I'm sure, but it'll come to me as soon as we're off the call.
Of course. Of course. Well, I'm setting up the NCSE meeting with you down the road, so you'll have time to remember.
I'll cogitate. Yeah, but check out Spying on Whales by Nick Pyenson. It's a really lovely book.
Yeah, that's a great book.
Yeah.
Thank you.
Oh, yeah, okay, good.
Leslie.
Oh, can I ask somebody one thing?
Yes.
One thing that's helping me recruit teachers is if someone could take a picture of this and tweet it, I will retweet it, so it'll
I got it.
Creates the fear, creates the FOMO, so I can get more teachers involved.
Of course.
So over the summer when we had our workshop, we did a Skype session with Lee Berger, and he spoke very candidly about his the struggles and barriers that he faced through his career with just the unavailability of access to information and fossils, and how things were just kind of hidden in museum vaults for forever, and you had to know somebody who knows somebody who knows somebody to be able to even see these fossils.
Yeah, Anthro, sure, definitely.
Did you have a similar experience kind of moving through your
I was working on fish, so it's different. So people don't hide their fish, I mean, so it's my office when I was a graduate student was in the fish collection of a university museum. So I was surrounded by stuff. I gotta say, I've not had too many barriers. I've had a pretty easy ride of it. The only barriers the main barriers that I've had are I set a very high bar for myself, and I don't always achieve it. And, the Tiktaalik story is a case where we set a high bar for ourselves and we did achieve it, but there are lots of times when we didn't. But in terms of access to specimens, that's not been because I work on fish, it may be taxon specific. You know, if I was working on hominids, it's probably a different gig than working on fossil fish, where like maybe 12 people a year might look at a particular, you know, collection specimen. You know, the biggest barriers for me early on were access to funding. You know, I didn't have access to a lot of money to do expeditions. So, but then again, that worked out really well. We focused locally, and in central Pennsylvania, that's where we had Ted and I had, you know, a lot of success back in the, you know, mid 1990s. So I can't even call that a barrier, because that barrier led us to, you know, to do something that ended up being successful, you know, and then enabled us to raise more money to do the Arctic stuff or the Antarctic stuff later. You know, allowed us to have stepping stones.
All right, other questions? I had one. I actually asked the same question to Dr. Berger when we met with him over the summer. If you could tell aspiring high school students one thing about a life of a scientist that maybe they don't realize, might not know about being a scientist, what is one thing that you'd want to communicate to them?
It's a life of exploring the unknown, which is exciting. You know, I mean, it's really is exploration, no matter what you do, whether it's looking under a microscope or going to Antarctica. Or working in a computer, it's exploring the unknown. And that's one of the greatest privileges of being human.
And that is very similar to what Dr. Berger said. So I think that's amazing. That is awesome. All right. Other questions? I don't want to hog the mic. Okay, well, if no one else is going to ask one, I'll ask one. Let's see. You have many areas of expertise: anatomist, paleontology, scientific communicator, researcher, professor. Which of those is your favorite and why?
Of the scientific expertise, my favorite is the expeditionary paleontology. Yeah, it has to be this. Come on, they pay me to do this. All right, you know, and that's like, you know, come on. I mean, you know, I can live in a tent and go to Antarctica and try to just talk about exploring the unknown. That's really physical. I mean, it's very physical working there. I mean, just look at this. I'll take a different background, give you a sense of it. Here's my favorite camp. Yeah, look behind me. Look at that camp. I mean, I lived there for 3 weeks, you know, and again, it's in a small tent at -40, but but those are the Devonian rocks you can see in the distance there, and they're just gorgeous. Yeah, I just love that. I love the thrill of the hunt. You know, I love the not knowing whether we're going to be successful or not kind of approach. We worked really hard to get here. We've chosen it very carefully, but you never know. And so I just like, that's very exciting to me. I like thinking about the logistics of working in the field. I like working with people in the field. You know, that requires a pretty broad skill set. You know, it's not always good weather. You might be stuck in a tent for a week or two, and you know, you have to really work with people as human beings, not just scientists. And I enjoy that.
Leslie, question.
Sorry, Andrew, did you have a question, or did I beat you to raise your hand? No? Okay. I was just kind of curious. So with all of the new technological advances that we've seen just in our lifetime, like how can you talk about maybe how certain advances in a particular type of technology has really helped you move along? Because you said now you're moving in, your department is heavy into molecular right now.
Yeah,
So,
well, yeah.
I'm just kind of curious, like what key discoveries or embellishments of current technology has really helped your field?
Well, there's a couple. So let me just give you a couple answers. So in paleontology, the biggest thing is high energy CT scanning, where we can blast inside rocks and see fossils in there, and 3D printing, you know, because then we can get the information out. So we can learn really quickly what's inside rocks. We can characterize the fossils. Plus, we can put all those data online so everybody else can access it. So access now is much easier than it was when I was a graduate student. In the molecular side, it's just been a revolution. Really, the last 10 years, it's been incredible. Not only has genome sequencing technology gotten so fast, but everything that depends on it has gotten fast. We can now look at it to see how chromatin is dynamic, how it opens and closes, how that relates to gene activity. We can now look inside an individual cell and see every single gene that's turned on inside that cell. We can look at tissues and do the same thing. We can ask the question, what is the battery of genes that make a retinal cell different from a cell inside a bone of your wrist? It's amazing to be able to do that. Furthermore, not only that, we can now edit the genome, which CRISPR-Cas genome technology works so well. It's cheap. It works on a lot of different specimens. It's not hard to do. And that's been a game changer because now we can edit genomes. We can knock them out. We can move sequences around. We can rewrite the code, and that's helped us a lot with understanding fish. Now, we don't do humans with that, but we work on fish that way. Frogs, fish, yeah, it works like a charm. And so we do that. So those have been really game-changing technologies. I mean, the main CRISPR-Cas paper came out, about 8 years ago. That got the whole thing going. Just 8 years, and look what the world is changing. So yeah, it's just like this incredible pace of scientific change, which lends me some hope about coronavirus, right? Because had we had this pandemic 25 years ago, it would have been didn't have the molecular tools. Now it's remarkable the speed at which the science on coronavirus is moving. We now know the sequence of the genome of this thing. We now know the structure of the spike proteins and the different enzymes that are active in it. We can now design drug targets to match those particular things. So there's a pipeline of about 78 vaccines already, 7 of which are in human trials already. That's science that would have taken years. It's now happening in weeks. And, likewise, all the different antiviral targets, so, the science has just gotten so rapid. And furthermore, scientific collaboration using Zoom, using preprint servers, using the ways that we can interact as scientists means that we can work collectively. We can leverage each other's discoveries. One of the things that's moving coronavirus research along so fast is we don't have to wait for peer review. People put their papers on archive servers, and then scientists can get directly into it, interacting directly with one another. So yeah, it lends me a great degree of optimism that science for the win.
Andrew, did you have a question and I missed you? Okay. I know that your time is very valuable, Dr. Shubin. You've already given us a lot of it. Are there any final questions before we let you go? I'm sure we could all stay here forever because we think you're amazing.
Thanks.
You have other things to do with your time than talk to us. Any
I
final?
have to get a car that's in the shop. So, they're supposed to bring it back here. I don't know what's happening.
I see. Very good. Other questions? Well, Dr. Shubin, I have to tell you, this has truly been incredible, and we so appreciate your time. Truly.
Well, thank you. And thank you for all you do with evolution education. It's really important at this day and age. You are the front lines, in many ways, and I'm more than delighted to support you with your important work.
Well, thank you so much. And just of our crew, thank you to John for helping to coordinate today's meeting, and to Molly for bringing us all together, Dr. Amanda, who spoke with us about evolution and religion, and truly, they all have made all of this happen, and you speaking with us today has just been phenomenal. Thank you so much.
My pleasure. Have a wonderful day and stay healthy. Take care.
Thank you.